Hey YouTube, it's Brendan with Cusack Prep. What I've got for you here is a video how to prove this particular trig identity. So fortunately, this trig identity, even though it looks really complicated, you're actually going to find that it's very easy to solve. And the reason it's very easy to solve is because when I look at it, I notice that we have the difference of squares. You might remember from Algebra 2 that the difference of squares is anytime you have a squared minus b squared, it can be factored into a plus b times a minus b. So for example, let's say I had 16x to the fourth minus 9. This first term is a perfect square, and so is the second term. So I can factor this into 4x squared plus 3 times 4x squared minus 3, just the square root of the first term plus the square root of the second term, and the square root of the first term minus the square root of the second term. So I'm going to use this in order to factor out the top here. The square root of sine to the fourth of x is sine squared of x. The square root of cosine to the fourth of x is cosine squared of x. So I get sine squared of x plus cosine squared of x times sine squared of x minus cosine squared of x divided by sine squared of x minus cosine squared of x. Now, fortunately, and this is super cool, sine squared of x minus cosine squared of x can cancel out on both the numerator and the denominator. So what I'm left with then is just sine squared of x plus cosine squared of x equals 1. And we know that sine squared of x plus cosine squared of x, well, that just equals 1. That's a trig identity, so I can say 1 is equal to 1. And there you have it. We've proven this trig identity in just a couple of steps, even though it looked really complicated when we started. So the lesson learned from this is always remember to look to factor, especially when you see something like the difference of squares. Thank you so much for watching.